Hello everyone, let's start with the basic of theory of computation. So let's start with language. So language can be of two types. One is normal language and another one is formal language. So normal language means sequence of symbols plus with their meaning. And if we talk about the formal language, the formal language tell us sequence of symbols. So according to this, formal language is the superset of normal language. So we in the theory of computation generally we study about the formal language. According to Chomsky, formal language can be categorized into four types: type 3, type 2, type 1 and type 0. It is categorized into two different category. One is set acceptor and another one is set generator. So if we talk about type 3 has a finite automata as a set acceptor and regular grammar as a set generator. If we talk about type 2 has a PDA as a set acceptor, context free grammar as a set generator, linear bounded automata as a set acceptor in type 1 grammar, and context sensitive language as a set generator in type 1 grammar. Similarly, Turing machine as a set acceptor and unrestricted grammar as a set generator. So till now Nargis Gupta has already covered finite automata, regular language and context free grammar. So let us start with push down automata, means type 2 grammar as a set acceptor. So let us discuss about the PDA. As the name suggests, PDA stands for push down automata. So what is the difference between PDA and finite automata? So PDA is equivalent to finite automata plus one data structure. Generally we have stack as a data structure. So as already talked about, finite automata does not have any extra memory to recognize something, while in PDA we have a one memory as a stack to recognize or to push anything onto the stack. So if we talk about the tuples of PDA, so PDA has the 7 different tuples. Some is similar to the finite automata and we have extra tuples for the stack data structure. So first tuple is Q. Q represent finite set of states. Second is summation. Summation represent is input alphabets. Third one is del. Del is the transition function. Fourth is Q0. Q0 represent initial state. Then F. F represent set of final state. Then triangle represent stack alphabet, and finally the last tuple is Z0. Z0 represent initial top of the stack. So if we talk about the transition function of PDA, so transition function of PDA represent Q. If we so first of all we generalize this. So if we talk about the generalized transition function, so generalized transition function is Q summation del tends to Q and del. So it represent if we are at any state q0, if we are getting any input alphabet a and our top of the stack is z, finally we are moving to the state q1 and push a into the stack. So this is the representation of how we can how we can move from one state to another state. So this transition so this can be represented by transition function like q0, if we get a as an input, our stack top is z, so we move on to the q1 after inserting a onto the stack. So basically in PDA we have three different operations. First is push operation. How push operation is going to be performed? So suppose if we are at q0, if we getting a as an input symbol and our stack top is z0, we are trying to push alphabet x onto the stack. So how we can write? We are moving to the state q0 and we are going to push x. So how this operation is going to be performed? Suppose initial top is z0, so how stack is look like? Our stack look like this. So how this operation is going to be performed onto the stack? So first of all, our stack top is going to be pop out from the stack, then whatever written on the right hand side, that symbol is going to be inserted onto the stack in reverse order. So first z0 is going to be inserted and after that we are going to insert x. So this is how we are going to insert x onto the stack. Now second operation is pop operation. How pop operation is going to be performed? Suppose we are at q0, our next input symbol is b and our stack top is x. So this is the situation of the stack k z0 then x. Now what we have to perform? We are trying to remove x from the stack. So how it can be written? So suppose we are not moving from state q0, we remains at q0, and if we are writing like this epsilon, so what is the meaning of this? Okay, initially what for every transition what will happen? The stack top will be removed. So what is the situation of stack? Situation of stack is our stack top becomes z0 and instead of x what we are going to insert? Whatever written on the right hand side. So what is written on the right hand side? Epsilon. For epsilon means nothing. So what is the stack top? Stack top is z0. So it indicates that we have successfully pop out the stack top x. Now move on to the third operation. So third operation is the escape operation. Escape operation means we do not want to pop something or we do not want to push anything. So suppose if we are at q0, our next input is add a and our stack top is z0. So this is the situation of stack, and now we do not want to push anything and do not want to pop anything. We just want to skip that. For the sake of differentiation, we are going to write C here. So suppose if we got C as an input symbol, we just want to skip that symbol. So how we are going to write that particular transition? So we are not going to change state, we are just writing Z0. So what is the meaning of that? As I already told you, okay, whenever we have to perform any transition, first of all, whatever the stack top is there, that stack top will going to be removed. So our stack situation after removing Z0 is look like that. After this, whatever written on the right hand side, we are going to push onto the stack. So Z0 is written over there, so it indicates that we are going to insert Z0 onto the stack. So our stack top is Z0. As already you can see, both stack are same, so it indicates that after performing this transition, we do not push anything and we do not pop anything. We remain, our stack top remains Z0. So with the help of these three operations, we are going to implement different automata. So in the next video, we are going to see how push down automata work. Thanks.